Hello. Today I'm here to talk about extracting the derivation builder from Nix. So as opposed to using it in the context of an entire store and all this other stuff, we can just build derivations in sort of the lowest level, most isolated way possible, separate from everything else. This is a picture that Prof. Patch, who I don't think is here, once made of me, that I'm very honored by. The idea being trying to do little things that Archimedes style with the right leverage can make a big difference. And on the flip side, on the Nix team, we've joked a lot about something more like this, which is my endless refactoring and shuffling the code around so the rest of the team can be confused about what is going on where and where to find it. And so ultimately, I think the cool part about this is there is a real, this aspect of product management idea or a planning idea about what we would do with a split derivation builder, but the actual talk I'm going to give is going to be much more nuts and bolts and much more of that. So, to cut a little bit to the more lever side, what really gets me excited about this is not just the sort of technical part of the how did we finally extract this code that was so long tangled with other things, but the idea that this might be a key way to get away from C++ and sort of the current implementation. As I wrote in the abstract, there's some parts of Nix, like let's say the daemon protocol and other things, where you're either going to get the code right and things will just work, or you'll get it completely wrong if you make a mistake. One parsing bug and your connection disconnects every time. And I'm a big believer in fail fast. When things actually reliably break, that's good for programming. That's good for debug cycles. And so rewriting, let's say, the daemon protocol logic, or parsing derivation files or other such things, it doesn't feel so daunting to me. On the other hand, the sandboxing logic is this like 20-year-old evolved thing that has all sorts of subtle behaviors, and you'd have to like go crazy understanding every nuance of how Linux works, how Darwin works, to exactly replicate it. And if you get it slightly wrong, maybe 5% of derivations will behave differently because of some complex system interaction. So that would be the part of Nix that I'd be most scared of re-implementing from scratch. And thankfully, with the work today, we don't need to. At least we can put that off while working on the other stuff instead. So that big picture aside, let's go now into the fun engineering nuts and bolts. For many years with Nix, there was this singular giant file, build.cc. And this contained a number of classes, but the three main ones I want to go over are worker, derivation goal, and substitution goal. Worker was this, this single-threaded event loop that kind of manages the whole thing. In the building case, it waits for the builder to succeed and close its pipe. In the substitution case, it waits for curl to finish its async downloading stuff. And like many event loops, it's sort of scary, and the asynchronous nature of what's being done means that all the business logic is sort of spread all around. But that's, at least it's like sort of known quantity, and a thing that other software has also. Derivation goal is likewise also pretty complex. There is what you'd expect, the normal local building case that has the sandbox, has the stuff we're going to be extracting today, and also the build hook case, where remote building, it's not just talking to the remote machine and doing that layer of RPC, it's actually 2 layers of RPC, because there's this little build hook process that used to be a Perl script, and Nix is talking to that to then talk to the remote builder. So all this and the complexities of getting the dependencies for the build, all of that was in the very large and complex derivation goal. And then finally, substitution call. I won't say too much about that. That is actually kind of what it says on the tin, and a good citizen in this world. So yeah, this file was far too big, and for many years that was just the way things were. But in 2020, about when I was getting started really contributing to Nix for real, Teofan and I split it up. This was just a purely mechanical change, moving the stuff around and not changing how it worked, but it was still a big moment of sanity for us, breaking up this giant file. And a kind of way to get started familiarizing ourselves with all the stuff Elko had written in it. There's the diff stats. As you can see, a bunch of little new files appear, and the build CC, which it decided to associate with DerivationBuilder, the biggest and scariest successor, lost a lot of stuff. So that was good. Next up, I wanted to separate the local building and the remote building cases. And I did this with a way I actually never really liked, but again, kind of getting a foot in the door with this local derivation goal split. So that worked like that. The single derivation goal class became two classes. And the derivation goal handles the remote building case with the build hook I mentioned, while the local derivation goal made the further assumption that we have a local store and has the direct building stuff. The awkward part, though, is this was way more OOP than it should be. Local derivation goal actually inherits from derivation goal and does everything it does too, so it also does the remote parts. The separation was not quite the right thing. There's the diff stats again. As you can see, the new big file appears and some stuff gets removed from derivation goal. And the reason for this sort of awkward division of labor beyond just kind of expedience is right here, which is a bit of code from worker. You can see it's picking which one to use, but this decision is happening before the do we want to build locally or remotely decision, which means that if we go with the local derivation goal, we might later want to decide to use the build hook mechanism after all, and why we have to keep that code path around. So this was like, again, sort of trying to make things better, but not really fully succeeding. And this was 2021, and it kind of just sat this way, an incomplete job for a while. Fast forward to today, or rather this year, however, and yeah, we've got the awkward subclassing. We have this also add wanted outputs issue, which I won't really have time to talk about, but this basically has to do with as you're traversing the graph, you don't always know up front all the outputs you need, since you get, you end up increasing that set in a sort of awkward way. And what I was just mentioning of the derivation goal is just, it's doing too much. The division of labor is not quite right. Finally, after 4 years later, after Planet Nix, sitting down with Las, I was like, I'm sick of this stuff at the back of my mind. We need to get it done. And so my talk today is basically about that process starting then and the bunch of refactors we've done between now and then and how it's finally in the state that I like it. So this is what we have today. The local derivation goal split is actually gone. But from derivation goal and bits of local derivation goal, we've made these 4 new things instead. We have 3 different types of goal mechanisms with the worker that now do much more one task, do it well, kind of Unix philosophy stuff. And then DerivationBuilder, which is completely separate from the event loop machinery and is just the sandboxing logic, and what I'm especially excited about for today. I hit there. Oh, yes. Yeah, I put it in a different color because this is not a goal. It's not associated with the worker. It has no sort of event loop scheduler opinions. It's something that you can easily use from your own system with your own way of managing I/O, exactly as I want. I'm just going to skip this slide for time, which talks about the new division of labor and those other 3 goals, and how that's worked. And now let's get to the derivation builder itself. So it's a very simple interface. There's just 2 core methods you need to know. Starting the build, which sets up the sandbox in all the ways that can happen. Creates the logging pipe that the builder process is going to be writing into, and then actually starts the builder. Apologize for using builder in 2 senses of the words. There's the new sense of this derivation builder class and the original sense of the process, the original process started by the derivation we call the builder. It might start other processes, but Nix doesn't super care about what it does once it gets going. So that start builder process is the original sense of the builder process and not the builder class. And then after there's unprepared build, which kind of does everything in reverse. You would call this once the pipe has been closed, which is a sign that the build is done or hopefully done, but we'll kill the builder process just in case it mischievously closed the pipe and didn't exit, then tear down the sandbox we set up, and then finally register the outputs left behind by that process, getting our final store paths in the store of a successful build. And however, I said at the beginning, the current way things work is all this requires a store, which is the main abstraction in the store layer, so named of Nix, that it's a giant class that does all the things. And if the whole point of this is we want to, in new implementations and other sort of new experiments, use this derivation builder interface, if it depends on the store, then we're kind of back where we started. Even if the thing we're doing is not trying to do everything like invoking the worker stuff, it still depends on everything as if it was trying to do everything. So the big question of if we are actually going to have reusable sandboxing logic is, can we get rid of this store dependency and have a much more simpler requirements? What actually it turns out is we can't get rid of it because it's only dependent upon in one spot. So setting up the sandbox, so this is just regular system calls, formatting strings, low dependency stuff, as long as you've got your operating system interfaces, which you of course do. Creating the pipe, same thing, that's like totally POSIX, totally portable. Starting the builder process, also. Killing everything, again. Tearing down the sandbox, again. It's only the register outputs that is where we actually need to interface with the store because we're trying to tell the store about the data we left behind. And that is sort of an intrinsic dependency. If we're trying to register things with the store, we need the store by definition. So what to do about that? Essentially, move the goalposts. So we'll make register outputs its own step after unprepared build. We have a slightly more complex interface, but now the things which are totally portable are no longer encumbered by this registering output, which is separate from unprepared build. And so for the external clients, again, for that early side, the main motivation here, if you don't have the local store, you can just skip register outputs and do your own thing, exercise left to the reader or the implementer in this case, but you get to fully reuse the rest. So we're doing the best we can, and it's still a major improvement from the status quo. I think that would beg the question, like, is this, is registering outputs like super complex, and like does avoiding it like still give us benefits? And I think the answer is actually totally yes. Like I said at the beginning, the sort of really complicated, subtle, you have to know everything about the kernel to get it right is really the first start build, and then tearing down is a little easier, but it goes with it. Registering the outputs is somewhat complex, more than I should be, but not in the same kind of subtle, deep OS knowledge required way. Also, ask me about this later, but I have some ideas about whether we should be leaving the data behind for registering outputs to pick up at all, or we should do a sort of RPC way of registering things instead. For my other big project going on right now, dynamic derivations, CA derivations, I think the RPC way is actually just better, and that's also really convenient for this because it means we would no longer have this after the fact registering outputs, and instead we'd have this on the other side of the RPC registering outputs. And so that sort of further separates these tasks in a way that I think is very good for both the new features and also the organization of the code. So I think it is actually quite sustainable to say registering outputs is just completely separate from this, and its successor will not even be as complex. And certainly the current registering outputs and its successor, the new RPC thing, are both less subtle and hard to get right than the starting build and unprepared build. Okay, so with all that done, let me again figure out how to not look at my fingers as I type and show you this stuff in action. I'm gonna just get it set up on the laptop screen and then move it over to that workspace. Okay. So now I'll crash my computer building things and read the code with you all. Okay. So here is via the C API, how you would use this from another language with nice bindings to use this stuff without any store. I'm going to ignore that for now. First, I'm getting derivation specified not in the language, but in JSON out of a file. This is a very simple, no dependencies. You just use the impure bin sh to echo some text. I would show you that, but I kind of don't want to mess with my windows anymore. It's not been so good today. So just take it on faith that this is going to be like echo foo angle bracket $out or something like that as the build step. Now we're going to make a store directory. This normally would be done by opening a store, but we don't want to do that because the whole point is to show we can build things without using the normal store infrastructure. Then we're going to start with our string of JSON, and we're going to parse it and make the internal derivation opaque type from the interface. This is hidden. The details of the type are hidden behind the C API, so it's just a black box behind the pointer from our perspective. Sorry, here we're going to create the storer. That's just setting up the config. Here we have no input paths because there is no peer dependencies. Here we're going to pick where we want the build to take place. And then here we need a DRV path, and sort of the funny thing is since we're only doing one thing and all the worker stuff has been avoided, this can actually just be an arbitrary string just used for warnings and errors. And then finally, we're going to make the derivation builder, the new abstraction. Then we're going to start the build, and then we're going to finish it. The finishing call will block. I could have written the wait for the pipe myself, but I'll just let it do it. And then intentionally not done is the registering output, since we don't have a score, and then tear down everything we did. So in my final minute, let me see if I can run the unit tests here. So the name of this one is going to be Build Using Builder. And yay. Okay, it worked. I'd love to take questions now, but I have 14 seconds, so find me afterwards. Thanks.
All right.